All right, we're doing it. I guess it is on. What is best in life, Conan? That's not the answer. Does anybody here ever watch any old Arnold Schwarzenegger films? Come on, what is best in life, Conan? To crush your enemies, to see them driven before you, and to hear the lamentations of the women. Yes. Oh, yeah, that one is going to go off until I actually power it on to start recording. Which, how many minutes do you got on your time? All right, I'm just going to walk up there here shortly and actually, I guess I might as well just start recording now. It's not like I can't cut it down later. Yeah, it works for my purposes for this. I have much better ones at home, but it's like, I don't want to pack everything. That looks good. And I guess we'll consider this the pre-talk show. And test of equipment. Cool. All right. And everybody can hear me just fine. Just let me know whenever you want me to actually start the presentation. So how many people is this the first time at PhreakNIC? How many people it's the second time? How many has been coming here for like 5 PhreakNICs or so? Got a lot of regulars. Cool beans. Well, I've given this presentation one time before. Hopefully it's a little bit more polished. I've added more information. But unfortunately, I always talk long. And the distinct problem I have is I know on PowerPoint slides you're supposed to just get to the main points of discussion. But I really want people to be able to go back and do some more research on this. So I've embedded a lot of links into the PowerPoint presentation, and they'll be available on my website relatively shortly after I get back. There's an earlier draft of this PowerPoint presentation that's out there right now, but there's a few links that I've added actually just a few minutes ago, thanks to Billy, that hopefully illustrate some of the points I'll make better. I don't know, just the idea of people who are so into privacy that they'll design these really intricate networking and security features. And I just thought it was really interesting, not to mention there was this wild and whirly feeling with the internet when I first got on it. My first experience with the internet was at a university campus, and it was like all this information out there and all these unexplored places, and the internet's kind of lost that feeling. But some of these darknets, even though there's not a lot of information out there, it still has some of that Wild West feeling that the internet did sort of, I don't know, 93, 94. Well, apparently we are ready to go. Hello, my name is Adrian Crenshaw, and this presentation is on Darknets, fun and games with anonymizing private networks. A little bit about me. I run Irongeek.com. Anybody ever been to the website? Groovy, glad to hear it. I can always use the traffic. I have an interest in InfoSec education. I have people asking me questions all the time on how do I get a start in the information security career field. And I'm like, you do? This is a hobby for me. Someday I'll probably do it. But my main interest is actually educating other people about computer security topics. I don't know everything. I'm just a geek with time on my hands. This sounds like something similar to this is what Bruce Potter seems to say in front of all his speeches. Take everything I say with a grain of salt, especially some of the stuff in this presentation. There's some intricacies about the encryption involved and how different nodes on a network peer each other that I'm probably going to get at least slightly wrong. I've actually had some emails sent to me by the developers of one of the darknets I'll be talking about, correcting some of the mistakes I made. So if I made some mistakes, just come back to me after the presentation and we'll talk about it, and then I'll try to correct them if I ever give this presentation again, because I'm interested in knowing what the actual truth of how things work is. But let's go on to what this talk is actually about. As I said before, darknets. But I really feel I have to define that term because people use the term darknets for all sorts of things. Some people use darknets as meaning my own little private click network where me and my friends are, but no one else is on. Some people use darknets as an actual public network, but it's all anonymized to each other and everything's encrypted. And some people use darknets for sections on a network set aside that don't have any traffic or aren't supposed to have any traffic and aren't being used. And the corporation might set up this darknet so that whenever someone tries to connect to one of those IPs in that range, they know that has to be malicious traffic because there's no legitimate traffic that should ever go to that particular network. But that's not the kind of darknet I mean. I just mean a anonymizing private network. Generally speaking, these are going to use encryption and proxies of some kinds, nodes or peers talking to each other to make it confusing who a message originally came from. Some people, and this slide really isn't for this audience as much as the last audience I had. Some people might say, well, isn't the internet fairly anonymous in of itself? People, post on 4chan and feel anonymous enough to say all sorts of things that get their asses kicked if they did it in a bar. The internet's somewhat anonymous in that sense, but I mean, IPs can be associated with ISPs. Bills have to be paid to these ISPs. That's going to tie it to a name and a bank account. Websites log IPs as a matter, of course, of who's connecting. So if someone wants to go look at those logs, how good they are about, retaining them for long term is a different issue. But it's possible to connect someone to a particular message sent on the internet. Also, a lot of protocols out there on the general IP network is plain text protocols, so people can sniff them and see what's going on. If you want more information on some of those topics, I have a whole bunch of links out on my website, details on what information you can pull from just having someone's IP address, a quick intro to using sniffers, and some on footprinting and scoping, which is essentially you got a few factoids about an individual or a computer and how you can find more information about that particular person, how one little factoid leads to another. But let's continue on. Who cares about darknets? At least my definition of darknets that I presented a few slides ago. Well, the first group would be privacy enthusiasts who are worried about censorship. Firms can be worried about it from a policy compliance standpoint. They might be worried that someone's getting on a darknet and downloading things onto the network that they shouldn't, or possibly someone might be using a darknet to leak information back out. For instance, WikiLeaks, it has its own little Tor hidden service version that people can communicate with, and I believe they might even have a version on the I2P network. I don't quite recall at this point. Also, law enforcement might care, because these private anonymized networks have completely legitimate uses. However, there's also a fair amount of bad stuff going on, and I'll get a little bit into that in a bit. So, why would you care if you're an average citizen? Well, do you want to stay anonymous online? Some people really don't like any information about them being out there on the public internet. I remember a while back, I think it was it AOL that released information that they thought they had anonymized about people's internet searches. But based on the internet searches, people were able to piece together, well, this lady, apparently she lives in New Albany, Indiana. She was searching for petunias and how to plant them properly, and she has acid reflux. All these little factoids that eventually lead you to who the person really is. So people want to stay anonymous. Sometimes it's for reasons like peer-to-peer file sharing. They don't want to knock on the door from the MPAA saying, why are you pirating this particular movie? Some people might be worried about censorship. For instance, if you're working out of, let's say, Iran or China, you might be worried about people interfering with your rights of free speech. And, as I said before, privacy. Other people that might care, corporations. Two main reasons. I'd say people leaking trade secrets and personal identifiable information. And also, sometimes someone might use darknets for getting around corporate firewalls and so forth. I've seen various people implement web filtering solutions that are easily bypassed by Tor. Not that they can't block Tor, but they don't. Law enforcement also might be an interest. And my understanding is at least 3 presentations this con that has Pedo Bear featured someplace in the slideshow. There is a fair amount of contraband out there. If you're web surfing around, I'm going to give you a few tips to try to keep yourself legal and not to go to some of the darker places on some of these darknets. But there are some criminals out there. There's supposedly some terrorists. I haven't personally seen much terrorist information. I've seen documents leaked out that claim to be terrorist training handbooks and so forth, but nothing I can really tie down. And yeah, there are apparently a lot of pedos out there. All right, some key terms that I don't really think I need to cover for this particular audience. Proxying, encryption, signing, and small world model. I think the first 3 this particular audience should probably have a good grasp on. small world model, some of these darknets basically operate as a series of nodes that all communicate with each other, and they peer with each other to send information on, so you don't know who sent the original factoid. Oh, thank you, sir. Well, let's make this a PhreakNIC tradition, because I think last year you also brought me something to drink. Sir, I thank you much. Anyway, now I have no idea what I was going to say. Small world model is the one thing in here I think I might need to explain. Who's ever heard of the movie game 6 Degrees of Kevin Bacon? Essentially, the idea is even if you have like thousands and thousands of people in some kind of social network, if you think about the connections, it only takes so many connections to get to any one individual in that. And some of these anonymizing networks work that way. For instance, PhreakNIC and I2P work that way. And I'll be talking about those two specifically later on. But everybody's pretty familiar with how proxying, encryption, and signing work, correct? Okay, let's continue on then. The first darknet I'm going to talk about is Tor. If for no other reason than it's the one everybody thinks of first, it seems. Now, first of all, let's talk about, and I'm going to do this for each one of the darknets I'm going to discuss, the who's, whys, and what's and how's of them. First of all, Tor, which stands for the Onion Router, it was started off as like a U.S. naval research project. But then the EFF took it over, Electronic Freedom Foundation, and now it's its own little 501c3 nonprofit organization. If you want to find out more information about them, go out to the torproject.org. Also, if you want to know why, essentially they give a nice little mission statement of why they've created the software and are continuing to produce it and develop it. But more than anything, it's about personal freedom and privacy. What you can do with it is access normal internet sites anonymously, and, well, semi-anonymously, I'll go into that in a bit too, and use something called Tor Hidden Services. And finally, the how of it is you have this locally run SOCKS proxy that you can connect to with a web browser or some other SOCKSified application and put data out there onto the Tor network. Now, a quick explanation of how Tor works. The first thing it does is Tor, when you set Tor in your box, it's going to talk to the directory servers. And it's going to get a list of servers out there it can connect to. Then it's going to establish a connection to 3 of those boxes out. And what's going to happen is it's going to be encrypted at least on 3 levels. Who has ever played with, ever seen Russian nesting dolls? We have a doll inside of a doll inside of a doll. That's kind of what Tor works like. They call it the Onion Router because you have those layers upon layers. So I might pass a message on to Brian, and it's encrypted with all keys, but it's also inside that encrypted with my keys between me and Billy, and from Billy to Skydog from wherever the hell he is in the conference right now. If I was to illustrate that visually, and that's one of the reasons I did this. Actually, let's see. Let's say I am the public router. Let's say you, sir, hand your blue line to Brian here. And then someone who also has a blue line, hand it to him. All right. You, sir, let's say you want to talk to the public internet. You would send the message out after this tunnel's been built. And let's say you pull on your cable. He sends it back out to me. And through all this, it's encrypted. Now, this doesn't illustrate it well because it all looks the same, but there's different keys for each one of us along the line, and basically levels of encryption are taken off each time away. Here on the red, I'm the out proxy, or I'm the Tor exit point. Out proxy is a term that I2P uses. The red indicates, in this case, unencrypted. One of the problems with Tor is so many people think about it as being, and go ahead and keep your blue lines, they think of it as being for security, and it's not quite for security. It's for anonymity, which is what I always had problems saying, because that exit point can very well be unencrypted. There was actually a hack I'm going to talk about later on where a bunch of people at, well, there's some debate about exactly what was going on, but one theory is a bunch of people at embassies around the world were using Tor to connect to their private email. But the email they were connecting to was using POP3. As a lot of people in the audience know, POP3 passes its passwords and user credentials in plain text across the network. So yeah, it was encrypted while I was in the Tor network, and it may have been anonymized, but now all of a sudden, once it comes out, you know the person's email address and their password. Lovely. Now, later on, someone else came up with the theory that maybe this wasn't actually the people at the embassies using it. It was actually attackers trying to crack into these email accounts, and they were using the Tor network to anonymize themselves. I honestly don't know. But that's a quick illustration of how Tor works. And once it goes out the endpoint, it's unencrypted. Tor also has something called hidden services, which are really cool. And this is more along the lines of what a darknet really is. A Tor hidden service, who has ever watched a TV show like CSI or some of a crime drama where one of the protagonists is somehow locked away in a room someplace or in a coffin and they have a webcam on him, and everybody who's his friend can watch him die, but none of them can figure out how to do an IP trace or a whois lookup to figure out who the hell's running that webcam and where it's at. You all have seen that, right? I remember a CSI episode like that. It was like, okay, trace out, this is the ISP. Okay, who's leasing that line? Let's go there and let's fan out and find the person. Well, with hidden services, you can really kind of do some crap like that. The way a hidden service works is you throw data out into that network, and anonymously, it peers things in such a way that you don't really know the true identity of who you're talking to, if it's implemented correctly. There's exceptions to everything. The Tor hidden service, it works by, first of all, it's going to talk to the database, and let's say Bob's going to offer up a hidden service. He advertises in the database, and by the way, this directory server, that's one of the key weaknesses of Tor that I'm going to talk about here in a bit. Let's say Alice wants to connect into that. She finds out about it from the directory server, and eventually they agree via a rendezvous point and some introductory nodes, and finally start communicating with each other. But neither one of them necessarily knows the true IP of the person who's originating the connection, nor the person who's serving it. This is great for putting up onion sites. Tor hidden services that basically serve up web pages of information, but you don't know who you can connect to, who you're connected to. Who has ever heard of TorChan? TorChan is, who has ever heard of 4chan? Think of 4chan, but a fuckload nastier because the people are actually anonymous or semi-anonymous. That's essentially what TorChan is. It's basically an image board that's hidden inside the Tor network. And no, I don't recommend going there, but if you do go there, make sure you turn on privacy mode on your web browser so it's not saving images. Just take my word on that. If you were to see what Tor actually looks like on your machine, you got your little Vidalia client there. You're also going to have either Privoxy, or they replaced Privoxy with something else recently. Another little socks thing that's supposed to sit there and strip out things like possibly cookies and JavaScript and things that can possibly give you away. Because everything is advertised in that directory service, it's really easy to know if someone's coming from a Tor network, assuming it's the public Tor network. You can see I've modified my website to whenever someone visits it, it actually gives you a slightly different image in the top left-hand corner. And so you know you're coming from Tor. But that's essentially what Tor looks like. If anybody actually wants the source code for knowing whether or not someone's coming from Tor, I have the, well, first of all, these links here. These are some common applications and sites that might help you with more information about Tor. First of all, if you want to know how to set up Tor, most of you all should have no problem figuring that out. I have a video on that, and the Tor project website's URL was listed earlier. Another nice thing about Tor site, they've now started releasing a package, which is basically a portable version of Firefox, and all the stuff you need to run Tor, so you can keep your regular web browser configured just the way it normally is, and have a separate web browser you can run from a thumb drive that has a connection to the Tor network. It's kind of like what, oh, there was other people who did it before, but now Tor has their own sponsored one. All right, there's also Tor hidden services. If you want more information about setting one of those up, I have a video on that as well. And if you want to look around at these different Tor sites, these Tor hidden services, there's actually a proxy that you can get to from the public internet called tor2web.com, where you can visit this and don't have to install Tor at all and see some of these hidden onion services. The thing that I question about Tor2web is what their liability is, because there's some images I know are being hosted through them, and I believe they also do some caching. And if they're like caching stuff that's from TorChan, I'm not sure what the legality of all that is. And if you want an example of a Tor hidden service, that one at the bottom, now that link's only going to work if you're connected to Tor, but that's the WikiLinks, the Tor version of WikiLinks. You see it has a dot onion on the end. When someone has a dot onion on the end, Tor knows to, the proxy for Tor knows to route it into a Tor hidden service. Okay, pros and cons of Tor. First of all, nice thing about Tor is if you can tunnel it over a SOCKS proxy, you can pretty much make any protocol work. That's pretty nice. I've seen some people have some problems getting like Skype to work and so forth, and I still haven't found any really good answers on UDP-based protocols. If anybody has any information on that, come to me after the talk because I'd like to know. Also, the free levels of proxying where I talk to somebody, he talks to someone else, and he talks to someone else before it gets out to the internet really helps with the anonymity. The cons, of course, are, one, it's slow. Two, how much do you trust your Tor exit nodes? I want to talk about a little compromise that, well, I mentioned the embassy hack a while back. Anybody can set up a Tor exit node. You can set up one at your house. Not that I've ever done anything like that, but I have this friend, well, me and Paul Asadorian have this friend named Bob. And I know this guy, not personally, but Bob, who set up a Tor exit node at his house and put Wireshark on it and just sat there and sniffed all the connections and see what people are doing. Just to figure out, all right, are people really using Tor for political dissidents, or is it for porn? It's mostly for porn, or so Bob tells me. The screwed up thing about it is it's not really necessarily porn that would be illegal in the United States. It's a lot of Asian porn. But then again, some Asian countries have really draconian laws when it comes to pornography. So I guess that kind of makes somewhat sense. Now, another con it has is it has a semi-fixed infrastructure. For the public Tor, I was talking about that directory server before. Well, anybody can query that directory server to find out what nodes are out there on the network and then block them. As a matter of fact, on September 25th of this year, China actually blocked 80% of the Tor relays. And there's some more information at these links. But a nice thing that people have done is set up bridge networks. Essentially, what they do is they don't advertise themselves in the directory server. They act as bridges, and they might, IRC each other and say, this is a bridge. Connect to this bridge, and then I'll connect you to the main Tor network. So it's never advertised in the directory services, and hopefully the Chinese government never knows about it. Also, it's fairly easy to tell if someone's coming from a Tor exit server. Those things are going to be in the directory server, unless you're running your own customized version of Tor like Irongeek does. A little bit more than that in a bit. But if you want code for detecting whether or not someone's coming from a Tor exit node, check out my website here. I have a little implementation in PHP. I use it, a little function I made so that I could do that little image in my top left-hand corner. But it can be easily modified for other things, like if you want to go to your bulletin board and make sure no one from Tor can use it. This is something for people to look up later on. These are basically the local and remote ports that Tor works over. Most of the time, Tor network traffic is going to be going over port 443 and port 80. What's normally on port 443 and port 80? Correct. So now imagine if they really look deep into the protocol, they can probably tell it's not actually HTTPS traffic. But it helps that it looks like something that's non-invasive. Now, if someone has some kind of proxy server between you and the rest of the world that interprets SSL, maybe something else would happen there. I'm not sure. I haven't got a chance to really test on that. And if you want more information on Tor, there's a couple good links there. One I think I mentioned before, and the other one is, who are here knows Mubix? Mubix has some great detail on Tor out at his website. Also, I mentioned this a little bit ago. Some people have taken Tor and made a private version of it. For instance, does anybody here own an Irongeek? Overpriced perhaps, but really cool little devices. One of the things they come with is this thing called Secure Sessions, Private Surfing. And it's its own custom version of Tor. When you fire it up, you use Irongeek's version of Tor. And they've, instead of having to go out someone's cable modem someplace in Kansas or Amsterdam, you're going through people's higher speed data centers when you make your connection to this particular Tor-based network. The downside of that is, how much do you trust the company? I asked someone from the company, you're not monitoring this, are you? And they said no, but I mean, it depends on how much you trust Irongeek. It is a whole lot faster, though, than the public Tor network. Another anonymous network I'm going to talk about is a Nanonet and Darknet conglomeration. Essentially, these are people who have rolled their own little Darknet using OpenVPN and BGP routers. Essentially, the idea, well, here's the links for them. They both seem to run, so you can do semi-anonymous network-based protocols. And you can say somewhat anonymous because here's the problem. Ultimately, you have to have an entry point into this. And I haven't been able to get on a non-net for several months. Essentially, you've got to have a VPN configuration that talks to one of the VPN servers on a non-net, and then the routers will eventually route you to whoever's hosting the IP address. But each router in there knows who his personal peers are. So it can kind of, with some work, yes? To my knowledge, yes. It's a virtualized internet. But the nice thing about it is any old IP-based protocol that will work over OpenVPN will work just fine. The downside is, depending on how you're peering, like you're running a node on the network, he's running a node on the network, he's running a node on the network, you each know about each other. Like, well, I'd hate to pull up strings again, but you're talking to Billy's, you're talking to Brian, talking to Billy. Give me B names. You know, you may know who he is, you won't know who Billy is. He knows who you are, but Billy doesn't know who you are. That's semi-anonymous, but since you both know who Brian is, there's some traces along the way that people can find out information. Correct. So it's got its flaws. On the positive side, it's a lot faster. Here's a little graphical illustration of what I was talking about. This one's from Darknet, but Darknet and Anonymnet Alliance both seem to work. I got on Darknet recently. Unfortunately, there wasn't a whole lot of stuff out there that I saw. That doesn't mean it's not out there, it's just they're not necessarily telling you about it. The pros of both Anonymnet and Darknet is it's fast. The downside, well, and also any old IP-based protocol will work on it. The downside of all this is you're not as anonymous as using Tor. There's not a lot of services out there, at least not that I could find on Darknet conglomeration. And the entry points seem to disappear. Like I found an OpenVPN config that was supposed to allow me into the Anonymnet, and I haven't been able to get it connect to it now. What the traffic looks like, that all depends on how the VPNs are configured to work. But Anonymnet, the configs I've seen, seem to operate on these ports, and Darknet conglomeration operates on that port, at least for the config files I've seen. That brings me to the next network I want to talk about, PhreakNIC. I have no idea if when they decided to make a rabbit their logo, that they had this particular quote from Watership Down in mind. Anybody here ever seen the cartoon adaptation or read the book Watership Down? Okay, it's essentially about a bunch of bunny wabbits. You gotta say it that way, bunny wabbits. But there's a quote from the book saying, "All the world will be your enemy, prince of 1,000 enemies, and when they catch you, they will kill you, but first they must catch you." And to me, that just really, that really illustrates what Freenet is all about. It's ran by the Freenet project, but it's started by Ian Clark. In a way, it's not so much an anonymous network as it is an anonymous data store. It almost acts as well, I was asking Billy some questions about, you don't mind if I use your name, do you? He was about a different Darknet that had some dealings with before, and he used the terminology sort of like network raid, because you stick data out there and it gets mirrored across multiple places. And I'm going to try to demonstrate that here in a bit. And egad, it's getting warm. Okay. Thank you very much, man. I understand it hurts the sound, but egad, it gets a little warm in here. All right. But Freenet's used for like publishing documents. And you can do some other things with it as well. The way you access it is via locally run proxy server of sorts. But everything seems to take place in the browser or in a particular application that's written for it. Here's more or less the way things work on Freenet. You might make a request for a particular document. Whoever you request it from may not have it. So he requests it from someone else. And they don't have it, they might request it from someone else. And someone might eventually serve back a part of it. And it might go through several different nodes, but eventually, and this is one of those things where I said that the peering and the cryptography seem beyond me. Eventually, you get the reassembled file, hopefully, back at your machine. And also, as people go out and request this information, nodes along the way that are passing the message back cache it. So something that's requested a lot is probably going to get served up faster. Something that's never requested might eventually disappear from the network entirely. whenever you join into, all right, when you join into something like Tor, you choose whether or not you're a server. If you're using a PhreakNIC, you basically are a server, but you don't necessarily know what you're serving. You have data that's encrypted on your hard drive, but the way they do things is you might have child porn on your hard drive, but you don't know it. But no one else necessarily knows it either.
Well, you'll never have an entire copy.
You have
an encrypted slice.
You have a slice of it. But depending on what that slice is, it still gets you interested. So think of it, like I said, I really like that analogy of kind of a network SCSI. When you access PhreakNIC, you're going to do it over a web browser. There's other exceptions to that. And there's a couple of good websites out there, like Ultimate PhreakNIC Index, that has links to other PhreakNIC sites that you can go to. But essentially, you just install PhreakNIC, then go to localhost 8888 and surf around. Now, there's different key types on PhreakNIC. As an example, if I was to access that URL, it would bring up that aforementioned Ultimate PhreakNIC Index site. Now, there's different types of keys, different ways of requesting information. The first type is CHKs. These are keys for static content. For instance, I've inserted out there a PDF I made about trying to keep yourself safe at a HackerCon on a HackerCon's network. It's just injected out there one time, and essentially the way to request it is to request the hash of it, like the magnet links you were mentioning before. Another thing you can use is SSKs. These are signed subspace keys, and these were implemented so that you could have a key you can hand out to everybody, but still be able to update it. For instance, having a web version of my website that I update and put it out in the PhreakNIC that stays the same forever may not be what I want to do. I may want people to be able to use that same key to get new versions of the information that I'm publishing constantly. So SSKs can be used for that. USKs, my understanding, is a wrapper around SSKs to make things a little bit easier to handle. And then there's KSKs, so you can use easy-to-remember keywords to find a particular document. The downside of that is when people insert these into the PhreakNIC network, you can have collisions. So if you don't like the KSK someone else inserted with a certain name, you can insert your own, and maybe eventually it would take over. Like I said, this is my understanding of it. There's also two modes of operation for PhreakNIC. OpenNet, which lets anyone in, and Darknet, where you can manually configure which one of your friends are going to be able to access into your particular PhreakNIC implementation. Okay, most of the time when you're using PhreakNIC, you're doing it via a web browser, using that little local proxy and requesting free sites. But there's a few tools out there as well. JSite basically just lets you inject stuff into the PhreakNIC network. FreeMail is essentially an email server that uses PhreakNIC to stay anonymous. Frost is a pretty cool little application. It's kind of like a mixture of a form system and peer-to-peer file sharing, which is kind of neat. And Thor is something similar to that. I have yet to play a whole lot with Thor. I've messed around with Frost some, and it seems like a whole lot like using a Usenet client. PhreakNIC pros and cons. Once you inject something into the network, it can stay there as long as it's routinely requested. So I put something in there off my laptop. I don't have to keep my laptop up and running to serve it. It's out there on the cached internet version. It's out there on, basically the internet SCSI's drive. The internet RAID drive. It's really neat from that standpoint because I don't have to, keep my site up like I would if I was doing a Tor hidden service. It seems to do a damn good job of keeping things anonymous. Really, I'm not big enough on the crypto to be able to ascertain that myself, but they seem to have some really smart guys working on it. It's also, like I said, awesome for publishing documents without having to maintain a server. Downside, it is dog slow. Now, in newer 0.7 something releases, it seems to have gotten a lot faster. I've used previous versions. It was a lot worse. But now it's, depending on what you want to do it's not really, it's still not particularly fast. It's not really interactive. Like I said, its basic paradigm is to be a big data store. So you're not really having your interactive, you're not going to be seeing anything like Google Maps on it anytime soon. You can't access the public internet from it, but then again, that's not really its main purpose. And it's also UDP-based, which can have some problems, maybe a little bit more noticeable, because it doesn't, unlike Tor, Tor at first glance just looks like regular HTTPS traffic. PhreakNIC doesn't necessarily look like that kind of traffic. Also, it's not meant to pass standard protocols. I'm going to talk about this somewhat later about a weakness, but the whole fact that it's using UDP and it's not disguising itself as some other type of traffic is sort of a downside. Those places where you just care about people not knowing where you're coming from and you just don't want them to see what data you're actually transmitting. There's other times you don't want people to even know that you're using a darknet. Let's say you're in China and you're using one of these darknets and they know you're using a darknet. They may not care what traffic you're passing. Just the fact that you're trying to pass something without them seeing is enough to, bring the law down on you. What does the traffic look like? Well, like I said before, on your local host, TCP port 8888 is opened up for processing connections and grabbing PhreakNet sites. Some other ports that are opened up from the outside world that you might want to configure if you're running behind a NAT box. All right, the last network I'm going to be talking about, and the one I actually in many ways find the most impressive, is I2P, Invisible Internet Project, though my understanding that name is largely depreciated. Who here has ever heard of I2P? See, very few people, and I'm really shocked by that because, to tell you the truth, I didn't really mess with it much until the last few months. I'm really impressed by this project, and hopefully I'll be able to demonstrate why here shortly. All right, the people who are currently organizing it are the I2P developers. They were started by a guy going by the name J Random, and if you go to this particular website, you can find out all sorts of documentation about how I2P works, who's behind the project, and what all you can do with it. But essentially, its main purpose was to develop this overlay network. It's you're not really routing, I guess, straight IP protocols over it, though you can do that with something called I2P tunnels. It's basically meant to be a network overlay on top of the public internet that you talk to each other via these keys, and you talk to one node, that node talks to another node, that node talks to another node via in and out tunnels, and everything is encrypted point to point and in between each person, so no one can see what traffic is actually being passed, and no one knows who it's really coming from. What it's really used for most is EAP sites, which I mentioned PhreakNet sites. EAP sites are kind of like that. They're also kind of like Tor hidden services. You can set up a web server. It's inside of the I2P network, so you have to be connected to the I2P network to get to it. But in theory, no one knows who you're really hosting it from, assuming you don't have some kind of application vulnerability. For instance, if someone happens to find an exploit for your web application that gets them a command shell, and they happen to be able to type in ifconfig, well, I guess maybe game over. But in and of itself, they don't necessarily have to know who you really are.
So how is it different than Tor? Because a lot of the stuff you're describing with the mix mastering, relaying.
Yeah, it gets a lot more complex. Tor was a relatively simple line for me to draw. I'm going to try to illustrate that here in a bit, and it gets a lot fugglier. They refer to that thing as garlic routing sometimes instead of onion routing, and here's one of the reasons why. And this is my understanding of it solely. You know how onion, you have a layer upon layer upon layer. In garlic, you have cloves. You have a layer, but inside that layer, you may have little cloves that have other layers. Well, that could be messages from you. It could be messages you're passing on for someone else. And there's something called, and I'm getting ahead of myself here, but there's something called a traffic analysis attack. All right, let's say Brian is sending 1 gig of data out onto the network to Billy through several different people. People may not necessarily know what he's sending, but if all of a sudden this node just injected 1 gig of data, and this node just received 1 gig of data, and someone owns enough servers in between, they might be able to think about it for a second and say, this person sent this at this time, this person received this at this time, maybe these are the two talking to each other. They may not be able to know the data, but now at least the person is somewhat less anonymous. I2P has some solutions to that. One of the solutions to that is you have multiple in tunnels and multiple out tunnels. Another solution to that is garlic routing, where essentially your little message you're sending out contains part of your message, part of someone else's message, and you may be sending part of it out one tunnel and part of it out of a different tunnel, and receiving it back via one tunnel or a different tunnel. So it has a lot of things in common with Tor, but God, is it hard to actually try to illustrate. And once again, you have this own little locally run proxy of sorts to be able to connect to it. Here's the picture they give to illustrate how all this is supposed to work. And I'm not sure how well this works. Let me see. All right, those people who I handed a rope to earlier, a blue and a white rope. All right, we're going to say your blue is your outgoing. And you're going to say your white is your ingoing. So people have to get a little closer to me. All right, this is my outgoing. I'm going to send my outgoing to you. All right, send your outgoing to somebody and send your ingoing to someone else. You too, ma'am. Here. That's my incoming. All right, send your outgoing to somebody. Now, in reality, it'd be more complex than this because there's only one between me and her. But imagine a few more hops across this. I might be sending a message out this way saying, hey, send me this particular EAT site. And I think we're missing some connections here. I try to think of a good way to illustrate this, and this is the best I could come up with. All right, so, and how did you end up with two white cables? Give that one to Billy. He's not going to do anything with it. Just hand it to him. He doesn't get a message. All right, so basically I might request something out my out, and it's going to go several different places, and let's say he's the one that has it. He has it. He passes it back out his, well, that's his in. Oh, wait a second. Yeah, I pass mine out the blue, in through the white, so it goes to you. You, it's going to go to you. You, it might go to him. Him, it might go to her, and from her, come to me, although we're missing a blue line into her. Regardless, all right, I thought this was going to work better when I originally came up with the analogy. Here, let me have all the ropes unless you all really want to keep them. So that's why it's a lot more complex, and that's why I don't think this picture by itself illustrates it well enough. But you get the idea. Everybody's like peered together with each other with different in and out tunnels. And each one of us only had one in and one out. It's actually a hell of a lot more complicated in reality because you could have multiple tunnels in and out to multiple different peers, multiple different ways, different things can come back to you. As strange as all this is, it actually works really fast by comparison to Tor hidden services. Once you actually get integrated into the network, and it takes a while for you to set up enough tunnels to actually be well integrated, you have that small world model thing going on, that 6 degrees of Kevin Bacon thing going on, where you can send a message out there, and relatively shortly, someone who's actually supposed to get it does get it and responds back to you.
Does the speed be coming from like a torrent effect where you have like several, because you have these multiple in routes?
Yes, possibly. Like I said, I've been reading the documentation on I2P, and it's really inspired me to get better at the mathematics of encryption, and I need to get some more illustrations on exactly how the peering works. When you access I2P, most of the time you access it via a web server. This is the entry page. Now, I know you're not going to be able to read this. I'm breaking every single rule of creating PowerPoint slides, but I want people to look at my slides later on to know how to set up a Tor hidden service. Not Tor hidden, sorry, an I2P hidden service. They don't use the term hidden service. A lot of times you use the term EAT site because you're serving up a web server, but you don't have to serve up a web server. For instance, in these config pages, I've set up an SSH box to run over I2P so that I can host a shell, but no one in theory can figure out who's actually hosting that shell. In reality, once you connect to that shell and you did an IF config and then did a trace route, you'd be able to figure it out. But it's just to illustrate that you can host more than just a web server anonymously using I2P. And there you see there, I'm I2Ping into my home router. Now, it's too small up there for you all to see. I'm going to show a better example here shortly. But there's several different ways you can address something into the I2P network. First of all, pretty much everything is like these 516-character addresses. How would you like to type that in every time you wanted to access a resource? That'd be fugly. Luckily, there's names. There's something called Suzy DNS. Essentially, you're going to have some name .I2P. When you access this, this is actually mapped to this long key using your host.txt file, not the one that's sitting in your Etsy directory, but a different one that's sitting in an I2P config directory. And it maps these names to these keys so that you don't have to remember something long like this. Now, if you don't happen to have that particular name inside of your host.txt, there's these things called jump services that act kind of like a DNS server, and they will help you add this add these particular entries to your host.txt file. Also, you might have saw when I showed a Tor hidden service before, there was a bunch of characters, .onion. They have a similar concept for I2P. We have 52 characters, .b32, .i2p. These are called base 32 addresses. And these are something else you can publish out there if you want people to be able to access your hidden services. Once again, hidden services isn't the term I2P uses. They use the term eep site, but eep site usually means website. So I want to just show that you can use other things. Yes, sir? Oh, you mean as far as that I'm peering out with other people on odd ports? Yes. If someone came to your local machine and it wasn't something that was normally in your host.txt file just because you installed, I mean, there's only certain things in your host.txt file just because you installed I2P. But if there's stuff that was added later on, like let's say, what is it, for JSChan, don't go there. There's a 4chan.i2p, don't go there. But yeah, if that got added and then people looked at it later on, they know that you visited that particular site. Yeah, so that is a security concern if someone has local access to your machine. Point taken. There's some really cool applications out there using I2P. I've put up a primer on getting yourself connected to the I2P so you can mess around with it. There's an implementation of BitTorrent that comes with I2P called I2P Snark. There's actually BitTorrent clients there's BitTorrent trackers that run completely inside of I2P. And I've tried them out, downloading completely legal content that I had copyright to do. Unfortunately, so few people are using it, it's dog slow. It seemed that the problem wasn't I2P itself that was slowing things down. It was the fact that you're only connecting to like 3 other people sharing it that was making it so slow. There's an iMule implementation that uses the I2P network. Cindy is this thing that's like a blogging application they're working on where you can use Cindy for anonymously publishing news into I2P. There's also something called I2P Tunnel, which is what I use for setting up that little SSH session to publish it inside of the I2P network. It's also used for like freenet sites. That's not freenet sites, sorry. I got too many darknets on the mind. For publishing like EAP sites. By the way, I2P comes with its own little web server built in. It's based on, Jetty, I think it's called. But if you have an Apache box running on your home network, you can easily remap it to point to any old website, any web server you're running. But once again, while that's anonymous directly, if they can compromise your web server, there might be other ways they can figure out who you really are. Just keep that in mind. A few other cool services, though. There's outproxying. Tor is more focused on connecting you to the public internet anonymously. I2P is more focused on its internal privacy of people hosting services to each other without anybody knowing who each other is. But they do still have out proxies, but they have very few of them. Every connection I've ever made, I've always come out of this one particular server in Amsterdam. But you have the option of reaching the public internet. And strangely enough, despite the fact they have fewer they call them exit points in Tor, out proxies in I2P. Despite the fact you have fewer out proxies, it seems a lot faster than Tor. Maybe that's because very few people are using it. I'm not sure. Suzy Mail is kind of cool. Essentially, those are these mail servers that run inside of I2P that you can connect to. And when you send a message, it'll actually send it out onto the public internet for you as well. But when people respond, you don't have to use the public internet to get your message back. You connect to I2P. So even if a government subpoena happens to the mail servers, they still don't know who you necessarily are. Unless you've done something stupid like, what's that? Yes, or actually the people who run Suzy Mail make a comment that don't test it by emailing your normal public internet email address. Because then if Suzy Mail ever gets caught up in legal troubles, they go, the first person that Irongeek that I2P emailed was Irongeek at irongeek.com. So obviously, that might be the same person. Another great website to check out once you connect to the I2P network, check out this website, InProxy. They basically have a huge list of other EAP sites you can visit and which ones are up and how long they've been up. It's pretty cool. There's this really awesome blog called privacy.i2p that you can visit, and they seem to update that fairly regularly. If you want to mess around with I2P but don't want to necessarily install I2P, if you just want to see the EAP sites, if you go to i2p.to, it's actually a proxy, kind of like that Tor to web I mentioned before, but for accessing EAP sites. And the way you get to it is you type in the EAP site name, .i2p.to, and it should take you there. Unfortunately, it's not really good about correcting relative links, so you'll probably have to go in and manually type in EAP sites when you're jumping from one EAP site to another. Also, if you install I2P and you decide to configure your own EAP site, before you nuke and rebuild a box, you can't really regenerate these keys. If you want to be able to keep the same names later on, back up this information. Now, I've only installed I2P on a Windows box, both a Vista box and a Windows XP box. I'm not sure where it saves this information if you installed it on a Linux box, but it's probably going to be a similar location inside your home directory, probably. But on XP, this is the path to your I2P config, and on Vista and Windows 7, it's this particular path. If you go to nuke and rebuild your machine, back that up. That way you don't have to abandon your old name. For instance, I set up an Irongeek that I2P before I really had any idea what I was doing, and I deleted my config directory, and now I can't have Irongeek.I2P anymore. All right. Pros and cons of I2P, and I'm going to try to wrap this up quickly. Lots of supported applications. Granted, they're not running on normal an IP-based network, but people seem to be doing a lot of development for it. You can create just about any hidden service you like if you can tunnel it over SOCKS 5. And earlier I showed some screenshots of that. Like I said, download the presentation later on, look at the screenshots in depth, and it should show you how to set up a hidden service using I2P. Also, I hope to do a video sometime in the near future on that. EAP sites also seem somewhat faster than Tor hidden services. This is somewhat subjective. I haven't really sat down there and tested them side by side. But subjectively, when I request a Tor hidden service, it takes forever, it seems. But an EAP site, if I'm already well integrated into the network, it doesn't seem to take any time at all. A few cons. One of the cons I said at the last conference I gave this presentation at was that it was UDP-based. It's not. One of the developers, I think it was maybe ZZZ, contacted me and said it's not UDP-based. I was reading some old documentation from the Tor services that said it was UDP-based. It wasn't. I actually put a sniffer on it and read the newer documentation. It is TCP-based. Limited out proxies. So in some ways, it's probably going to be easier to block. Like I said, the only out proxy I know of is this one in Amsterdam that I always seem to come out of.
That's a honeypot.
Perhaps. And also, the out proxy doesn't handle SSL. No chance in hell of you being able to read that from that distance, but it's something you can look up later. For each individual service that application that I2P uses, it seems to open up its own particular ports on your machine to connect to locally. So there's a lot of ports associated with running I2P. But the remote ones are the main ones you might be concerned with, and that's usually 8887. And I've messed around with configuring it. That's 8887 TCP, though it can fall back on UDP if it has to. You can change that port that you're listening on. Unfortunately, you're probably still going to get a bunch of connections from other peers who are using 8887. So if you're trying to do this on a network that's being monitored, it's still fairly easy to know someone's using I2P on you. Okay, some common darknet weaknesses that apply to most of these darknets. One is traffic analysis, and I talked about this a little bit earlier using my example between Brian and Billy. Someone inserts a certain amount of data at a certain time, someone receives that same amount of data shortly thereafter. I have a pretty good idea who's talking to who. I2P has done a few things to try to keep this from happening. DNS leaks are another problem. You might have configured your browser to use its local proxy, the particular proxy, but if things aren't configured right, it may do its DNS queries through its general internet connection. And let me see if I can explain that. Well, let's say I want to find Brian.onion. That's not maybe the name, but I request Brian.onion, or actually no, let's say it's Brian.com. I try to connect to Brian.com through Tor. Okay, my connection for you is going over Tor, and everything between me and you is anonymized. However, I made a DNS request just a second ago for Brian.com from Billy's DNS server. Billy's monitoring his DNS server and saying, well, I don't know what traffic he's sending, but I know he just made a request for this particular host name, so obviously he has to be visiting it.
But won't this be addressed? That's a big problem with Tor, because Tor doesn't handle UDP, and DNS lookups are UDP, so you can't do DNS lookups over Tor.
But
if they support UDP, you could conceivably do a DNS lookup.
Well, they have other solutions because there's ways of configuring your browser, and generally when I've installed Tor as of recently, it seems to have automatically set up everything correctly for me to where the proxy actually handles the DNS lookup for me. So it's not an issue, though it's still something you should watch for. I'd recommend after installing Tor or I2P, fire up a sniffer in the background and watch for any DNS traffic. If you see DNS traffic, stop and look at how your things are configured. But yeah, DNS leaks is a concern with it, and the best way to do that is just fire up Wireshark, go to your filter, type in DNS, hit enter. Hopefully nothing comes up when you start surfing around with I2P or Tor. And in my limited experience with it, it seems to, after I do the install, automatically configure things correctly. Maybe your mileage will vary. And I'm still a little bit confused on HTTP proxies versus SOCKS proxies and where the name lookup actually happens. Another problem is cookies. Cookies can be used for finding out if someone's using is using a darknet. For instance, let's say I visit Irongeek.com using my public internet connection. This is neat. I want to hack it. So I say, well, I don't want him to know who I really am, so I'm going to start using Tor or I2P and their proxies to connect and attack Irongeek. Well, the first time you connected to me, I served up a cookie to your page. The next time your web browser connects to me, I see that same cookie again. So even though you're anonymized via your IP address you're coming from, since you served up that same cookie I gave you earlier, I know who the hell you are. If you want to see an implementation of that, what was that? Oh, so someone asked a question. Go to browser info on my website. Also, if you want some code for doing that, this is the PHP file. It's going to be rendered in your browser if you try going to that URL. But if you want to just download it, been there before.txt. It's a simple little PHP file that puts a cookie on your machine and keeps track of all the different IP addresses you've come from. So that's a good way of tying someone down to the real internet connection. Also, beware of plugins. In the past, different plugins have revealed people's true IP address. These first two I've listed, the one at hackers.org and evilhackermatrix.net. When I've tested it recently, I couldn't get these ones to work, maybe because they did some kind of correction in Tor. These ones, under the right circumstances, I could get to work against I2P, but not Tor. Essentially what they do is, depending on how things are configured, let's say it's a Flash or a Java applet that's being served up. In theory, if you configure things the way they're normally supposed to be, whatever proxy your web browser is set to use, your applet's supposed to use also. But there's limitations to that, and sometimes things escape. What basically the little Java applet did was it tried to connect to you without using the proxy. Once it connects to you without using the proxy, it knows your real public internet IP address. And these guys at Frost Jedi actually implemented something along those lines, which is definitely worth checking out. He had several different ways of doing it. The one he labeled Moz binding, I had the best success with on actually revealing my true IP address. Oh, that cookie example I mentioned before, here's basically what it looked like. If you run the code, it shows that I was connecting from this particular IP address originally, and then I was connected from this IP address, which it knows is a Tor relay. So it's revealed who I really am. By the way, neither one of those are my real home address. It's not. I was using someone else's public proxy service for this one. Legally, though, because they offered it for me. All right. Some other common .NET weaknesses, untrusted peers. We mentioned that a little bit ago in I2P. It's not as big a concern, perhaps, in I2P because everything's encrypted, and you're not necessarily going to be able to easily do the data analysis attacks because you might get part of the data that's intended for someone, and someone else may get the other part of it. Untrusted exit points of Tor is a big concern. Who has heard of Dan? I hope I pronounced the man's name right. Dan Egerstad. Yeah, he did something that some people were referring to as Hack of the Year 2007 because he came up with this huge list of like usernames and passwords for embassy emails that were being sent around. Well, they finally found out how he did it when he revealed that basically he set up his own Tor exit node and just sat there and sniffed it. That's all the guy had to do. And there's some good write-ups on that. Schneier on security has a write-up on it. And Encyclopedia Dramatica, while not a safe work site, has an interesting write-up on it as well. Keep in mind, if you want to mess around with doing this yourself in the United States, various wiretapping laws will probably make it illegal for you to monitor this traffic. Even though it's going on your own network, you're not necessarily analyzing it for reasons of keeping the network up and running. Maybe it's a legal gray area. I'd stay away from it myself because it's probably going to run afoul of wiretap laws. Educational purposes only get so far. I don't think that one's going to fly, unfortunately. People may not know what you're sending or to who, but they know that you're using a darknet, and that could be enough to take action. For instance, if someone's running a darknet on the corporate network, people may not be able to see what it is they're actually sending, but it's bad enough that someone knows they're trying to hide something. Same thing goes if you're like, using a darknet in Iran or something. Oh, by the way, if you want a really cool site to visit this particular URL later on and read it. He gives a bunch of tips on how to stay anonymous and keep things like the Java exploit I mentioned before or Flash from revealing your true identity, as well as cookies and so forth. Also, another thing to be concerned with is cache data and URLs on your local machine. You were mentioning that before, everything showing up in your host.txt file. That is the case, and it is something to be concerned about. But also just your browser caching URLs, people know what you've been to. I have a presentation I gave. It's like a 3-hour presentation on anti-forensics on how to keep and cover your tracks. Might be worth checking out. But when you're visiting these networks, definitely use use privacy modes if possible. Is Droops here? Do I have a little time left? All right, thank you, man. Sorry about taking some of your time. All right, opening holes in your network. Here's a few concerns. I'm not a lawyer, first of all. Go ask Trip. Trip's your lawyer, right? I'm just kidding. I'm not a lawyer, so I'm not sure about all the legal things on this. But if one of the things, if you're doing research on darknets, you might be somewhat concerned about opening holes into your own network. That's probably more of a concern if you're using that open VPN solutions I was mentioning before. Also, be aware of various crypto laws in your country. The United States is pretty open on that kind of thing. But other countries just using encryption could possibly get you in trouble. Also, there's a problem inadvertently downloading child porn. If you're going out and indexing some of these sites and going, okay, what's actually out here on these darknets? You're going to accidentally download some child porn more than likely. Now, technically, the law is if you see something, you can't download it, and you're supposed to report it immediately. So I understand. The problem is if you've seen it, you've downloaded it. I mean, if nothing else to memory, assuming you have hard drive caching turned off using privacy mode. So ultimately, you've broken the law right there, and it's on an anonymizing network, so there's nothing you can really report to the cops. I'm still trying to find some good legal guidance on what to do when you stumble across some child porn on these I2P networks. Though I've never personally done it myself, it's just something that I've heard that happens. You can turn off images on your browser. That is a solution. But then that's going to make a lot of websites look totally screwed up.
But it depends on your browser, because a lot of times they'll actually make an HTTP request, pull the graphic down, but they won't actually render it. So you actually have it.
Oh, I did not know that. It's good to have the web security guy around. Okay, and if you want some information on, I'm trying to find some good laws on this, and the best I could find while searching on .gov sites is this one at the Detroit FBI branch. Okay, a few other things to check out when you get a chance, and this is something I updated just recently. HP Veiled project. Billy Hoffman, I was actually able to pick his brain here about 2 hours ago, because I'd heard about HP Veiled, but I found out very little information about it. And a simple Google search for it, I mean, it was all press release stuff. But the Black Hat presentation has a lot more information on it, so go check it out. Essentially, it's a darknet that works kind of like, and correct me if I'm wrong on this, kind of like PhreakNIC in that you have this distributed data store, but it all runs in your web browser and a little bit on the server. There's like a little PHP file on a server that acts as a switch of sorts for routing information between the different people who have the JavaScript running in their client. And there's ways of making this server relay to this server, relay to this server. Is that all pretty much correct?
Yeah, it's essentially PhreakNIC, not a very primitive PhreakNIC, if PhreakNIC was an applet and not a thick client. So it's very easy. Y'all were talking about having traces on your machine. It pretty much just appears inside of your browser, and you clear your browser history, and all traces of the internal client.
Sounds awfully nifty. I hope they release this code to it someday. Yes, sir. Would you come up close? I can't hear you. I'm getting old. Yes, depending on what kind of key you use. I can't remember the names. Some types of keys, yes. Updatable keys, yes, you can. Okay, a few other things. Flash block, definitely a plugin you want to think about installing. You want to run as few things as possible. You want it to be as plain Jane a web browsing experience as possible to keep from inadvertently leaking your IP address. Also, look in the multi-switch. I have different Darknets configured on my laptop at the same time. It's kind of a pain to go into Firefox and configure different proxies. So I use multi-switch, a little Firefox add-on that allows me to quickly switch from one proxy server to a different one. So I can go from using IHP to Tor within a couple clicks.
Does that work on 3.0?
Yes, 3.5. There was no one called proxy switch that stopped working. Yeah. But this one works in the newest version of Firefox. Whippin, which is sort of like Hamachi, it's another project, but that's more of like a friend-to-friend darknet as I understand it. It's something I haven't done enough research on yet. Okay, I'm wrapping up so Droops can get up here. A few events I want to mention real quick. If anybody is in the Kentucky area, the Louisville ISSA chapter, or Kentucky ISSA, has these classes every 2 months or so we put on. Usually about 3 hours where we cover some subject. One day it was sniffing, one day it was Nmap, it was anti-forensics, a different day, wireless security, another. If anybody's interested in ISS meetings, they're good to go to, if nothing else, for free food. We have monthly meetings. Louisville InfoSec is a conference we put on in Louisville. I'm going to try to get some people at this conference actually to speak next year if I can. And of course, 3 of my favorite cons. PhreakNIC, not a con, and AutoZone. I highly recommend going to all of those. Thanks to ZZZ for answering all my questions about the IHP network. The folks at BenRev and Paul.com for giving me some input. The Louisville ISSA for their support. The Hacker Consortium for letting me come here and speak. And the people that come to my free ISSA classes. And Billy Hoffman for answering some last-minute questions for me. Free classes, that's the stuff on helping out. And finally, questions. Yes, sir. JRandom. JRandom. My understanding it's short for JRandom Hacker. Any other questions? Yes.
What is the answer to life, the universe, and everything?
42.
Oh, thank you.
I don't know, little small mice disguised as girls? All right, I'm going to let anybody wants to ask me more questions, go ahead and get with me sometime later in the con. And thank you for your time.